Good morning. So today we are going to study about the efficiency of merge sort. So whenever we have only one element, okay, the time taken is 0. Okay. But whenever we have greater than one element, so it will take n by 2 unit time for merge sort in the left part, then n by 2 time for merge sorting the right part. Then it will take n unit time to merge. Okay. So by using back substitution, you can find the solution. So in back substitution, we are going to take this. So t of n by 2 plus t of n by 2, 2t of n by 2 plus n. Okay. Now in back substitution, we are going to write the equation on the left hand side and right hand side. So what we are going to do is replace n by 2. Okay, wherever there is n, so just write n by 2. So what happens is t of n by 2 is equal to 2t n by 2 square plus n by 2. Okay, so now again replace n by 2 square. So this happens is equal to 2t of n by 2 cube plus n by 2 square. Now the same equation, okay, now we know the value of t of n by 2. Okay, this is the value. So substitute this value here. So 2 into 2t n by 2 square plus n by 2 plus n. Okay, so this becomes 2 square t of n by 2 square plus 2n. Okay, now 2 square t of n by 2 square. Okay, we know the value of this. So substitute this value here. Okay, so just the same value substitute here. So we get 2 cube t of n by 2 cube plus 3n. Similarly, the general condition is 2 to the power of I t of n by 2 to the power of I plus n by I. At this stage, we should understand that we should reduce this to the solution that we know. Okay, so now we know t of 1 is equal to 0. So this should be 1. In order to make it 1, 2 of I should be substituted with the value of n. Okay, so that becomes, so now 2 of I is equal to n. So n into t of 1 plus n into I. T of 1 is equal to 0. So substitute n into 0 plus n into I. Now take this equation, take the log on both sides. So this becomes log of 2 to the power of I is equal to log n. So I into log of 2 base 2 is equal to log n. So log of 2 base 2 is equal to 1. So I is equal to log n. Okay, so here we are left with n into I. So n into the I log n. So n log n. So this is the efficiency of merge sort. Today we are going to discuss about Master's theorem. So this Master's theorem can be applicable for divide and conquer. So the equation is t of n is equal to a into t of n by b plus f of n. See, this function should be represented in terms of n to the power of d, where d is greater than 0. So depending on what the function takes, what value the function takes, there can be 3 cases. So if a less than b to the power of d, or a equal to b to the power of d, a greater than b to the power of d. So now we know the time efficiency for merge sort is 2t n by 2 plus n. This we have solved by back substitution method in my previous video. Okay, so now equate this with respect to this equation. So here a into t to the power of n by 2 plus f of n. Okay, so a is equal to 2 and b is equal to, this is n by b, so b is equal to 2, and f of n is equal to n. Okay, now this n should be represented in terms of n to the power of d. Okay, so n to the power of d means n to the power of 1. So that means d is equal to 1. When d is equal to 1, we can represent it in terms of n to the power of d, which is nothing but n. Okay, so a is equal to 2, b is equal to 2, f of n is equal to n, and d is equal to 1. So now compare a and b to the power of d. A is equal to 2 and b is equal to 2. B to the power of d is equal to 2 to the power of 1 is equal to 2. So that means it is case 2. A is equal to b to the power of d. When a is equal to b to the power of d, then directly we can get the efficiency, that is, it is theta of n to the power of d log n. Okay, so this is simply direct substitution. Okay, so we know the answer. So just substitute the values. So t of n is equal to theta of n to the power of d log n. Theta of n to the power of d is 1. So n to the power of 1 log n. So n log n. So this is the efficiency of merge sort, which we have already calculated by back substitution method. So you can calculate the time efficiency by back substitution method or by applying Master's theorem. Master's theorem can be applied only for divide and conquer techniques. Okay, thank you. So I have prepared the time efficiency of Master's theorems for different techniques. Let us see merge sort. So we know that the merge sort, the time efficiency is given by 2t n by 2 plus n. So substituting the values, a is equal to 2 and b is equal to 2 and f of n is equal to n. Okay, so now n should be represented in terms of n to the power of d. So this is possible when d is equal to 1. So becomes when d is equal to 1, so n to the power of 1, which will be equal to n. So now take a, the value of a is 2 and value of b to the power of d is 2. So now in this case, if you compare a and b to the power of t, both are equal. So this belongs to case 2. When case 2, it is the theta of n to the power of d log n. Okay, so it is theta of n log n. Similarly for binary search, okay, it is t of n by 2 plus 1. So here f of n is equal to 1. See, n to the power of d should be represented in terms of 1. So this will be equal to 1 when d, okay, is equal to 0. Okay, so that becomes n to the power of 0. So n to the power of 0 is equal to 1. So now a is equal to 1 and b to the power of d is equal to 2 to the power of 0 is equal to 1. So here again it is case 2 because a is equal to b to the power of d. So it becomes theta of n to the power of d log n. So substitute n to the power of 0 log n. N to the power of 0 is 1. So it is 1 into log n. So log n. So log n is the time efficiency of binary search. Now coming to the max min. So it is 2t n by 2 plus 2. Okay. So this is the constant here. So f of n is nothing but constant. See, constant can be represented like 2 into n to the power of d, where d can take the value of 0. So it becomes n to the power of d. So n to the power of 0 is 1. So 2 into 1. Okay, so 2. So now taking a is equal to 2 and b to the power of d is equal to 2 to the power of 0 is equal to 1. Here in this case, okay, it is case 3. So t of n is equal to n log a base b. So that means n log 2 base 2, which is nothing but log 2 base 2 is 1. So n to the power of 1, which is nothing but n. Okay. Now coming to quick sort, it is same as merge sort. Okay, but this is for only best case and average case. In worst case, what happens? The efficiency is n square. See, Master's theorem can give only in average case. Okay, you should remember that. So for average case and best case, it is n log n. Okay, only for quicksort, the worst case is n square. Similarly, for Straussian matrix, okay, it is 70 n by 2. Okay, so it can be considered as 0 into n to the power of d, the function, which is plus 0. Okay, so 0 into n to the power of d. So a is equal to 7. Now it belongs to case 3 because a greater than b to the power of d. Okay, so that means n log a base b. So n log 7 base 2. So log 7 base 2 is 2.8. Okay, so n to the power of 2.8.